Welcome to aminacademy.com. In physics, about discussion about motions, we need a lot of quantities to measure, like distance, displacement, speed, velocity, acceleration, mass, momentum, energy, work, like a lot of information and lot of quantities we have to define and understand. For this, we need to understand the quantity about means scalar quantity as well as vector quantity. A scalar quantity have only magnitude. It is denoted by number and unit. For example, length. Length is in meter, kilometer, and centimeter, millimeter, micrometer, etc. It have only the unit length quantities. There is no direction where we are measuring, which direction we are measuring. We are not considering this is a scalar quantity. Like this, suppose weight of the body, so mass, not weight, mass of the body equal the unit equal kg, gram, milligram, like that. In this, we are not considering the direction to measure. Means wherever you measure the mass, it gives same unit, that is kg. Same amount means what, 5 kg of object, if you measure from which direction, that direction is not considered, so it is a scalar quantity. Even the time also a scalar quantity. We are not using the direction for this. Now next one, vector quantity. A quantity, vector quantity, a quantity which have the magnitude and directions. Suppose consider a velocity. Velocity is a vector quantity which means the speed of an object is somewhat given, means measurement 60 kilometer per hour, but velocity tells with that quantity which direction it moves. Means suppose the body, suppose consider a car. Here it goes in right side direction at 60 kilometer per hour, and left side also same 60 kilometer per hour. If consider the speed, both are same, but if you consider the velocity, here this right side 60 kilometer per hour in east direction, and backward, that is 60 kilometer per hour in west direction. So if you consider the speed with the direction, we consider this a vector quantity. Now the vector quantity have two quantities together. First one, the actual quantity, means the speed with the directions. Now we'll consider vector quantity in detail. Different types of vectors. Equal vectors. Vectors having same magnitude and same direction. Suppose consider this line, another same, the parallel, as well as the quantity, that length of this both line is same, as well as the direction is same, exactly same. So we can say this have equal vectors. Means equal vectors should have same quantity as well as same directions. Next one, like vectors. Vectors having same direction but different magnitude. Consider this line and consider another line. Here this both direction is same, but the quantity of first item is greater than the second item, so this type of vectors is called like vectors. Next, opposite vectors. Vectors having same magnitude but opposite directions. Here one vector going this direction and another vector going this direction. Here both vectors have different directions but same magnitude, means the quantity is same but the direction is different. Next, here unlike vectors. Vectors of different magnitude acting in opposite directions. Here one vector is going like, another vector is going like this direction. Unlike vectors, vectors of different magnitude, the both magnitude have different as well as direction is opposite. So this unlike vectors. Next is unit vectors. A vector having unit magnitude, it is also defined as a vector divided by its own magnitude. Here consider this vector. Suppose it have 1 centimeter, another one, suppose this here 1 meter or 1 kilometer, whatever it may be. Here we are considering the quantity, that is length is unit, 1 unit means 1 centimeter or 1 meter. This is called a unit vector. Means suppose a big line vector is a, we are considering equal spaces with 1 units, means suppose here in centimeter, meters, put 1 meter, 2 meter, 3 meter, 4 meter, 5 meter, like that. So each unit have unit vectors. If total vectors divided by number of each units, means here this line, suppose here 5 meter length up to from A to B. Now the unit vector can be considered that as magnitude of AB over number of units is 5. Unit vectors is suppose we can write this A cap. This unit vector is total length divided by number of units. Next one, orthogonal vectors. Orthogonal unit vectors. 3 unit vectors in the opposite direction of x, y and positive direction in of x, y and z axis of Cartesian coordinate system denoted by I, J, K respectively. Suppose consider this figure. Here this origin in 3-dimensional. Here the horizontal is x-axis and perpendicular to horizontal is y-axis. Perpendicular to both x and y is z-axis. Each is 90 degree spaced. Here consider this in x direction, consider equal units. Here these equal units, everywhere equal units. Now each units in x direction is I, each unit in y direction is k, each unit in z direction is, this is y direction is j, and z direction is k. Here I, j, k are orthogonal unit vectors. Orthogonal means perpendicular to each other. We are using small letters of I, j, k, which represents orthogonal unit vectors. Next one, null vector or zero vectors. A vector whose magnitude is 0. Suppose consider a point. Point have no magnitude in lengthwise, means it is called zero vectors. Means we cannot represent zero vectors in straight lines. So zero vector we can consider as suppose 0 vectors like co-initial vectors. A vectors having same initial point. Consider the vector, suppose consider a point O. A vector have this side A and another vector starting from same point O and going other direction in different magnitudes. These two vectors is considered co-initial vectors. Means OA, vector OA and vector OB are co-initial. Means co-initial means same starting point. Next one, coplanar vectors. Vectors lying on a same plane. Suppose this computer screen have plane surface. We are drawing any figures on this surface, which means one vector is here, another vector is here. Whatever the vectors is like, all are lying on the same plane. These are coplanar vectors.